Okay, that's the front side of the Superblender. You can see the drive motor on the right. It's a 75 horsepower motor. That's the hydraulic power unit that serves the gap adjustment system and the mechanical seal. That's the drive assembly with the gap adjustment cylinder, big block on the side of the assembly. It's the view of the drive assembly and the discharge from the extraction area. It's the back side of the machine, and you can see the clean out port, which is a 12-inch nozzle on the back side that looks straight at the rotor. This is a view through the cleanout port. You can see inside there's a straight shot the rotor, so all unprocessable material can be cleaned out like once a day, once a week, or whatever. This is the gap adjustment system, so you can actually control the position of the rotor in the machine. You can also compensate for wear. It's the view of the rotor and the extraction plate, viewed through the manway. You can see how the tungsten carbide insert interfaces with that extraction plate. Plus, this rotor is totally overlaid with weld applied tungsten carbide for wear resistance. You're looking at baffling inside the tank. Keeps the contents all moving downward towards the rotor. Okay, there's the top of the Superblender. This one has 2 inlets and a number of nozzles for other purposes like level, inert gas, so forth. Okay, today we're going to run the Superblender and grind some things up to show you what it does. We have our test setup here where we have the Superblender. We have it the extraction zone connected to a gasoline powered centrifugal pump, and we're taking flow out of the machine and putting it right back at the top. That way we can make the extraction zone work. We have a generator here that's going to power everything, and we're running all of that through the starter we have on another machine to make it all work. And what we're going to grind up today is located over here. We have, I don't know, a whole pallet of sheetrock or gypsum wallboard. There must be at least 500 pounds there. We're trying to make a highly viscous mixture, and we thought the best way to do that is to grind up sheetrock. And then we have a lot of cardboard boxes to throw in there. Next we have some Tyvek suits with rubber gloves. We have some rags, and we even have some sample bottles. Let me show you these. We're just going to throw the boxes of sample bottles in. We have half of them are filled with solid resin, rock hard, and we have others that are filled with red liquid, so that when the bottles disintegrate, it'll turn the water red. And so we're just going to throw all of that in to simulate throwing whole boxes of material. And of course we have some wooden blocks over here we're going to throw in. We expect it to take a long time to reduce those, but we'll just throw them in and see what happens. been running the machine for 1 hour, and now we're just draining the contents out to see what we got. I don't know if you can see that or not. I have a screen here. I'll put it over that stream and see what we catch. Actually, that's pretty fine. It's just so thick. It has some chunks in it. That's resin right there. Fiberglass resin. That's actually finer than I thought it would be. Part of a blue. That's part of a glove right there. Got some rags in it. Okay, I just wanted you to know that I took some amperage reading on the main drive motor at various times during the run, and converted the amps to horsepower, and this is what we got. When we run the machine at no load with no water in it, it consumes 20 horsepower. When we fill the machine with water and run it, it consumes 30 horsepower. And this viscous mixture we just produced, the peak horsepower was 40 horsepower consumed. So you can see that this 75 horsepower drive has plenty of capacity to produce a highly viscous mixture.